Hello, my name is Scott Lacey. I'm a fire protection engineer with a background in municipal firefighting, industrial firefighting, as a former AHJ, and in the code development process. Today we're going to take a look at the Enhanced Rural Fire Water Regulations. This video just provides an overview of the regulation. Then there's additional videos that break down each section. Important to understand is that this video is based on the updates in the version at the time the video was made. It's intended as an overview. Specific content and wording in the video is subject to change within the updates and the regulation. Please refer to the latest regulations for the current criteria. So one of the key objectives of this regulation is to bring various codes together, including the International Fire Code criteria. And in this case, for the Colorado version, which was established and started in Colorado, we incorporated local planning and development codes. We also looked at the recently developed Colorado Wildfire Resiliency Code and incorporate criteria from that. We used NFPA 1140, Standard for Wildland Fire Protection, chapters 10 through 18. And note that section 15.2 of the NFPA 1140 has a requirement for an established water supply within 5 minutes. It may be a little hard to achieve, but it is something we kept in mind in developing this, is trying to get an established water supply as quickly as we could. NFPA 1142, the standard on water supplies for suburban and rural firefighting, is the document we used as a basis to establish the quantity of water that was needed. Now, we did not use this totally or directly. We modified, but we used NFPA 1142 as a starting point in how to calculate, but we did modify the calculation procedures. We reference NFPA 24, which is a standard for private fire service mains, as we incorporate that into the regulation. We also worked with representatives from ISO, or VERISC as it's being known now, which is part of the insurance services offices. This was used to ensure and help with the ratings by the insurance industry to keep them as low as we could, and that we were staying within their objectives. Now, how this regulation will benefit you as an AHJ or the developer is we're trying to incorporate the components and objectives of various codes and standards into one document to make it easier to use and easier to apply. A lot of those other documents reference back to the AHJ. They'll have a general statement that says water supply shall be provided, and that's it. So the objective of the regulation is to help to define and standardize what that means. Better structured for the property owners, the developers, the designers, and the fire authorities to find all these various components in one document. Standardize the expectations up front so we can avoid different criteria for each project. Nobody likes the rules changing from project to project. Standardize the expectations across the jurisdictions. Make it easier that whether you're building in subdivision A or subdivision B or jurisdiction C or jurisdiction D, we want to standardize the same criteria so that everybody understands what's expected. Developers need to know the rules before they start budgeting and planning. Again, nothing's worse than to get to plan review stage and find out that something different is going to be expected. This way, everybody knows up front what is expected. The regulation is intended to allow easier implementation and adoption as a regulation versus the formal code adoption. So in accordance with the International Fire Code, you are allowed as an AHJ to establish other policies, administrative procedures, and regulations in the guidelines and other precedents of the IFC on the interpretation of how to apply it. That's what this regulation does, is it brings the various documents together and fills those gaps where it says provide water supply, but doesn't tell you how to provide the water supply. So the regulation is just that. It's a regulation, does not have to go through the formal code adoption process in most cases, but it helps to clarify the expectations to achieve those objectives. Now let's take a look at structures versus the wildland hazard. We still need water. And what I mean by that is that traditional codes and standards base water requirements on the structure only. So if you look at NFPA 1142 or the IFC and you follow the criteria for calculating the water supply, it is based on the structure only and doesn't take into account what the fuel load is around the structure. It doesn't address the hardening or the mitigation of the structure or the trees or the wood deck or the mulch or the combustible fences that are around the structure and pose a significant risk. So the regulation incorporates wildland water requirements based on these mitigation factors. Now, mitigation, again, covers multiple things. It's not just the fuel load of the trees and the bushes or the grass or the piled up junk that's combustible, the wood pile, the shed. It's incorporating a lot of these various factors, including the hardening of the structure, protection of the vents on the structure to keep the embers from getting into the attic. So when we look at mitigation, the criteria of the regulation generally assumes a low fire intensity, which would be a lower quantity of water. This is based on what we assume to be a lower risk, a slower growth of the fire due to the trees being trimmed and kept away from the house, not having combustible wood decks. So we anticipate a ground fire with limited brush. We could have a grass fire and trimmed grass up to the house, and as long as we don't have a combustible exterior on the house, the structure will probably be protected. But obviously if that gets into a wood deck or wood mulch, rubber mulch around the house, we have different hazards there. And then if you don't provide the level of protection appropriate for the mitigation that's in the regulation, or in this case, the Colorado Wildland Resiliency Code, and you get into the medium or high fire intensity, there's going to be requirements for higher quantities of water due to the defensive protection of the structures that's needed, as our fire is anticipated to be up in the trees and the crowns and a lot hotter with blowing embers. The landscape and the slope can also affect these. So the level of mitigation may be different for a house that's on a slope with the fire running up the slope versus out on flat prairie land. Now, we do recognize the benefits of residential sprinklers, and we do apply credits. It's important, though, for firefighters to understand, a lot of people and developers and all don't understand that sprinklers are not intended to extinguish the fire, but rather control the fire when the sprinkler is located within the room of origin and until the fire department arrives. This is especially true for residential sprinklers. Although it's very common that 1 to 3 sprinklers will control a fire and contain it, and many times it might extinguish it if it's in that room. For residential structures, it is only intended to delay the escape of the occupants. So the intent of residential sprinklers, again, is not to extinguish the fire, but to allow more time for the occupants to get out of the building until the fire department can get there and extinguish the fire. This is the reason why attics and often garages are not protected. So if the fire starts in a room that is not protected by sprinklers, then the house can totally burn to the ground, and as long as everybody got out of the house okay, the sprinklers did exactly what they were supposed to do. So it's important to understand that. Yes, we like sprinklers. They do provide a benefit. They do save lives, but we still need water. So when we're looking at credits, it's fine to give a credit, but we don't want to give away all of the water, as we still need water for that exterior hazard as well as the structure. So let's look at some key concepts of the regulation. The first thing we want to do is validate whether we have a municipal type water supply that can be provided in lieu of cisterns. It is not our objective to have cisterns at every property. That's not what we're after. What we are after is to have a reliable, acceptable source of water for every structure. So the first key is to validate if we can provide a municipal type water supply with a positive pressure. Then we need to establish what's the flow requirements for that municipal system in a rural area. Do we want 250 gallons per minute, 500, or greater? So this is going to depend on the hazard, on the mitigation levels, and what the system can provide. An important thing for firefighters and AHJs to understand is just because a municipal type water supply may be in the area and they may be able to provide a higher pressure or great flows, it may not be feasible for a house or a subdivision. We would like to have larger pipes for more fire flow. However, the water department has to address health and safety issues of the water and the turnover rate. So if there's not enough domestic usage to turn over the water in that pipe, it's not going to be feasible for the municipal type supply to work. We end up with other health and safety and bacterial issues. So just because there might be a water source that sure they could extend a 6-inch or a 4-inch line, if there's not enough domestic usage for the size of that pipe and the length of that pipe to get the turnover, it's not going to be feasible. So we've got to work with the water provider first and establish, based on the domestic usage and the day-to-day usage, is it going to be feasible? We encourage and support the sharing of cisterns among the adjacent properties. So if a municipal system is not going to be feasible, and we're going to end up having to provide water sources such as cisterns, and we generally are going to refer throughout the regulation as cisterns, because where this is primarily developed is in freezing cold areas where freezing is an issue. So we want cisterns buried in the ground versus above ground tanks that now we have to insulate and heat. So in the regulation, we do support and encourage the sharing of cisterns. So if you have multiple properties that are next to each other, and they can go in and do an easement and address the legalities of that cistern. Who's providing it? Who's paying for it? Who's maintaining it? Who's allowed to use it? Okay, who's going to do the repairs on it? Who's going to keep it full? All those need to be addressed. But if that can be addressed, then we encourage the sharing of the cisterns. And this could be residential or even commercial properties, or in subdivisions this will apply. Now generally when we get into subdivisions, we're looking at larger subdivisions, we have a centralized cisterns, and we're going to look at a distributed private fire main and hydrants. So when we get into a large subdivision, if it's a rural subdivision, there's no reason it should be treated any different than a suburban subdivision. We should have reliable water to provide to those houses, and we have insurance and ISO criteria that we're trying to achieve. So this is where NFPA 24 comes into play. And we need water for commercial businesses and other hazards. So depending on what is going on, if it's a structure or outdoor hazards, such as idle pallets or a wood shop or auto repair, just depending what those hazards are, we need to address those appropriately. And that is covered in the regulation. We look at the cistern volume. So we talked about we have means to calculate how much water is required. And the spacing of the water supplies and the connections. How many cisterns do we need? How often do they need to be spaced? How are we going to achieve the spacing of the hose lays from the water source to the house? We also address the connection from the fire truck to get around the house. Now, as a general rule in the regulation, it assumes that the fire department has a bed of large diameter hose that can provide a 1,000-foot lay. In this case, we require the water supply or the connection within 900 feet of an acceptable parking area, and we'll look at that. As the acceptable parking area is generally going to be within 40 to 60 foot of the structure, typically out in front of your driveway, garage, out in front of the structure. So the 900 foot is to allow for that extra slack in the loops between the hydrant going up the road, reaching around the truck. So 900 foot is what the base criteria is in the regulation. However, this distance can be reduced for fire departments with less hose on the truck. So let's say a rural fire department only carries 500 feet of hose. They may want to reduce this. They may want to say 500 foot. They may want to drop it down to a 400 foot lay, to allow for that extra hose again, connecting to the hydrant, how it snakes up the road, the turns, and also the loop to connect to the truck. So within the regulation, say a county adopts the regulation, there's criteria in Appendix E where you can have specifics for each department. So each fire authority can still have their own custom, in this case, length of the lays, if they use 4-inch fittings versus 5-inch, storts versus threaded. Those can be customized by each fire authority where multiple authorities have adopted the regulation. Hand lines from the truck to the furthest part of the structure we require is 300 feet, not to exceed that. Again, from the parking area to around the structure is 300 feet. The local jurisdiction can change that, increase it or reduce it, depending on what they carry on their truck. Private fire mains and hydrants are required when the cistern is not within the distance acceptable from the parking area of the primary structure. So if we can't get the cistern within the connection and the dry hydrant connection of the cistern within the 900-foot lay, then a dry hydrant system would be put in. So, or it could even be a wet hydrant. And we'll look at that with subdivisions. We actually have wet hydrant systems. So we actually draft out of the cistern, draft back into the private fire main, and the fire department pressurizes the system. But this can vary depending on the configuration. Also, terrain is an issue, so we need to look at elevations and slopes. But if multiple houses are sharing the cistern, we may end up running one section of pipe to get to that far house down on the end of the road. But that can all be varied, again, depending on local requirements and the house. There are provisions within the regulation to have other options when additional criteria is satisfied. So this is not a hard rule, but it is the intended goal to achieve the insurance objectives, and for insurance, and not only to hopefully reduce rates, but the challenge now is even being able to get insurance. So we're trying to make sure that at least you will have an insurance company that is at least one, if not multiple, that will provide insurance based on the risk. So when we look at the water quantity for individual properties, the area of the structure within a 50-foot encroachment is what this is determined on. And this is the area under the roof line and each floor level. We get this concept from 1142 of NFPA. Now, NFPA 1142's calculation method actually looks at the volume of the house. So you have to look at attic slope, how much space is in the attic, the volume, and also what your ceiling heights would be. What we've done is taken that volume part of it out of the equation, and we're focused solely on square footage. But that is square footage under the roof line and the square footage of other structures that encroach within that 50 feet, which is per the NFPA criteria. We'll look at that in examples here shortly. Now in subdivisions, it's a little bit different. We're focused on the number of lots and the acreage per the subdivision. Are these going to be 1-acre lots, half-acre lots, 2.5-acre, 5-acre, 10-acre lots? So that's going to have an impact on the water requirements. So we're looking at so much water per dwelling unit, but also the acreage within the subdivision. Now the area of structures, including the encroachment, still comes into play. And we'll look at that in one of the other regulations. one of the other training programs. I don't think it's in this one, but the other modules we'll look a little bit more at how that's calculated. And then we also talked about the wildland water based on the mitigation. So depending if the assumption of the base amounts is that you're going to maintain and have a low fire intensity and you're going to maintain mitigation. Otherwise, there's going to be increased water requirements for medium and high. And we also address the hardening of the structure, the defensible space, and the tree spacing around the structures. So we're not only looking at the structure in this regulation like most codes, we're looking at the hazard outside that poses the risk to the structure or from the structure spreading to adjacent structures. Here's a drawing that's in the regulation. This is a snapshot from one of the pages. And this is used to help with calculating the area encroachment and the mitigation. So if we look at this, we have the primary structure. And we talked about the roof line. So even if we have a patio that comes in here, a covered patio, what we're focused on is the roof line of the structure. If we had multiple stories or basements, those have to be accounted. An unfinished basement still gets calculated. Unfinished basement often has a higher fuel load than a finished out basement just due to the storage and the accumulation in there. And that's going to change once they build it out or don't build it out. So basements all get counted. We look at the total square footage, but we're also looking at the encroachment within the 50 feet. So if we have a shed that's adjacent to the house or the chicken coop, or we have an outdoor kitchen, these are all become encroachment and square footage areas that are used to calculate. Now in this case, we have a detached shop that's greater than 50 feet. So as long as it's outside that 50 foot, that square footage does not get calculated. Now, the flip side of that is if you had a shop that's a larger square footage than the house, then that shop would become the driving factor. So the worst case condition of these scenarios is what's going to apply. We look at the mitigation to keeping the trees away from the house, the bushes away from the house, other landscaping, the wooden decks, all that gets factored in as part of the hardening and the mitigation controls. We have the general parking area we talked about. The acceptable parking area is assumed to be 40 to 60 feet from the primary occupancy. So this is where we would have to get our hose lay to serve the truck. And then from this point, no more than 300 feet to any part of the house, depending which way you go, taking into terrain and landscaping or slopes. If you have a structure here, we still need to be able to get within 300 feet of that hose lay. So we just need to account for that, and the acceptable parking area may be a little bit different for that structure, but we need to make sure we can get a hose lay around to the fire hazards. Now, if we're looking at a subdivision, here's the concept that would be applied here, is that typically we're going to have a water source such as cisterns. Again, this is assuming we do not have a municipal type water supply. So if we can't satisfy the criteria for a municipal type water supply, now we're into having to provide a water source. And in this case, we're going to have cisterns. In this example, we have 3 cistern tanks located right here. We have what we call the system inlet hydrant, where the fire truck is going to draft out of the cisterns and then pump into the hydrant. So this is a specific hydrant with different fittings on it intended to be pumped into. That truck, one truck there, is then able to draft and pressurize all the hydrants within this subdivision served by these cisterns. Now, if the subdivision is big enough, we may have multiple cistern locations with independent hydrant systems. Calculations have to be done to establish what the friction loss, the flows, the elevations are, to see if one set of cisterns will serve all this and within the limitations of what the truck can provide. But the nice thing here from the firefighting standpoint and the property owners is we can have one engine company or one truck and one driver drafting and pressurizing the whole subdivision versus multiple tenders going back and forth doing relays and shuttles, tying up people when we need boots on the ground. Let's say we've got a wildfire coming through this area and through this subdivision. So one truck is pressurizing all of these hydrants that now the firefighters can spread out here from multiple hydrants to provide structure protection. So that's a key thing, difference between the subdivision criteria and the individual properties. And in this case, each of the properties has individual wells, so they're large enough acreage that they're doing wells. And that's where we're using this as all a non-potable hydrant system. If you could come in here with a municipal type system and pressurize it and keep it all potable water, that's the preferred means. Now, before we look too much to get into the cisterns individually, I want to talk about eductors. Adductors have been proven for a long time, and they're used in many cases for rural firefighting. And many of you may have seen these types of adductors, and some may not. This is typically what's seen as one that goes into the lake or into the creek or into the water source. Now, the concept of the adductor is that you use the tank water on the truck to initially pressurize this line coming in. There's a nozzle here that forces a straight stream at a high pressure, creating a Venturi effect. So as the water is pumped from the truck to get it started, this Venturi effect draws water in from your water supply to increase the flow that's available. And then in this case, because now we're pressurized on the discharge of this, we don't have to use hard suction. So we can draw water from a source using a pressurized line to pressurize the Venturi, and then soft hose again to the truck, and we don't have to have hard suction. So in this regulation, where we have certain quantities, we exceed certain quantities of water or multiple tanks or hazards, the regulation incorporates one of these adductors, such as this type that's on the ground. This gets incorporated into the tank, one of the tanks. It may not be all the cisterns, but at least one of the cisterns would have this incorporated into it. Now, some of the benefits of this include that you can do dual or twin tube drafting, allowing one truck to draft from 2 tanks, increasing the flow. So even if the tanks are tied together, you could have one hard suction connected to one of the tanks, and we'll look at this in a little bit. But you could also easily set this up and take advantage of the Venturi effect and the adductor to get increased flow. Another truck could utilize this to increase flows, or to be filling tenders from one tank setup while another truck is drafting. So there's multiple options here. If you have a department that's going to be responding for mutual aid but does not carry hard suction, they still can get water. So the thought is why have 90 to 100 plus thousands of gallons sitting in a tank that we can't get use of? So this provides redundancy, but it also allows adjacent departments that may be responding for either a structure or wildland fires to be able to get water out of those tanks. Also, with hard suction, there's a lot of risks. We don't use the hard suction until we need it, and then we find out that the gasket has dry rotted and fallen out, or the gasket is cracked, or we've got a hole in the hard suction. And any of you that have done drafting know that if you get any air into that suction line, you cannot get a prime. So that creates problems and limitations. So you've got all your eggs tied up in that one basket, as you'd say, and due to an air leak, we can't get water out. With the adductor, it gives us another option that we can get water out without having to rely on hard suction or missing gaskets. So it provides a redundancy and additional means to get water out of those larger sources. This would not be used on individual properties. It's intended for subdivisions where we have a lot of water that would otherwise just be sitting in the ground that we can't get out. So in this case, an example that we looked at that subdivision floor plan or site plan earlier. This is where we have 3 cisterns side by side, and let's say these are 30,000 gallon each. So we have a total of 90,000 gallon nominal capacity here. So we have parking area criteria for 2 trucks. So we can have the primary truck that's going to be hooking up to doing drafting. They're going to draft out of the cistern, turn around and pump and pressurize back into the inlet hydrant. Okay. Another truck could be pulling up here to be refilling these tanks. So if it's going to be a long, drawn out fire, you may have tenders that are still coming back in and refilling the tanks. You may have other trucks here boosting the pressure. You may have other trucks here refilling their tanks. So depending on the fire conditions, but we have the criteria called out here for 2 trucks to be able to access this. In this case, where we have the 3 tanks and the 90,000 gallons of water, this end tank here would be incorporated with an internal adductor. So there's a separate pipe, you'll notice here, that's going in to pressurize and then the push the water out. So this truck, even though it can't pull up and get the hard suction from the side of the truck, say it doesn't have front suction and it can't get up close enough to get the hard suction on, they could still use soft hoses and get water out of the system. Now this particular case, these tanks are all tied together. So we have in the bottom of the tanks, and we'll look at this a little bit ago, we have the tanks come out and are tied together with an 8-inch line. So that way, as one tank is drafted, it's being refilled through gravity of these other tanks. Okay. Here's a basic tank. This is more of your individual property. So for a single cistern that's not interconnected with other tanks, just show a concept. When we're dealing with high altitude and elevations, drafting lift is a real challenge. So as we get into mountainous areas or high elevations, being able to draft that water from a tank way down in the ground or under the truck becomes more challenging, and it affects the amount of water you can draft. So the concept here is showing that as we excavate the hole for the tank, we mound that back up over the tank, and here's the road surface. So you see that the road surface is kind of offset from the berry of the tank, which reduces our lift. So we have criteria in the regulation as to how far this can be and what the limitations are to ensure that the trucks can get a proper lift and a proper flow. And then we have a level gauge, we have a vent, sometimes they're incorporated together, we have the manway. So this drawing is in the regulation, again, just incorporate some general criteria. We have a typical FDC type Siamese connection for refilling the tank. So that's what's being identified and depicted here. Now, if we look at a little more complex, like in a subdivision configuration, this is where this diagram shows that we can have a gravity feed. So let's say we put these cisterns up on a high spot in the subdivision. Then we could potentially have a positive pressure feeding hydrants. And depending on the slope and the elevation of that subdivision, you could potentially get 20, 50 or more PSI at certain hydrants, depending on the elevation with respect to this tank. So this shows a gravity feed connection that would be going out and serving that hydrant system. So you could have water even before you get a truck here to start pumping and pressurizing the system. You could already have water to your distributed hydrants. This particular case, it shows the eternal eductor mounted in the tank. We have a pressurized line that comes in and pressurizes it and then goes back out where you can use your soft hose to get your supply to trucks that do not have hard suction. Also included in the regulation is a detail that shows the typical layout and configuration. This would be more so for a subdivision. And in this case, it's on a protective pipe barrier wall or a retaining wall where the tank is mounted, but also provides a place for all the fittings and the signage. So as you look at this detail, just as an example, in this case, it's serving a cistern that has an internal eductor. So this would be the pressurized inlet. This is going to be your connection for your drafting, dry hydrant drafting outfitting. This would be your Siamese for refilling. In this case, if you have multiple cistern tanks that are tied together and gravity feed, there's isolation valves. We have electronic tank monitoring if that particular situation requires electronic tank monitoring. We have a post indicator valve that would be associated with the inlet hydrant, and this is where you have gravity feed, and so that as you're pumping into the hydrant, it's not just going back in the underground and filling the tanks versus going down the subdivision to the attack trucks. So this would be left open normally, but as you start pressurizing the line, you would close this valve to keep water going to the trucks, but you could leave it cracked open to allow some recirculation back into the tanks just for cooling. That is addressed more in the regulation, and it'll be part of operational training. So this handout again is in the regulation with additional criteria just as a kind of a layout and format for signage. Some additional content that's addressed in the regulation is criteria for permits, submittals, inspections, and commissioning, inspection, testing, and maintenance criteria, fire lanes, road width, loading, clear heights, and etc. So a lot of this is pulled from the IFC criteria and brought into the regulation. There's standardized forms and detailed drawings such as you've seen here, but there's also some standardized forms such as checklists for plan review and submittals, a standardized form for the municipal evaluation of the municipal type water system that you could fill out information and provide to your water company to evaluate if it's feasible or not. Appendix C allows for easily adapting local criteria such as the hose length, the hose size, fittings, etc. Again, a good case example is where multiple jurisdictions adopt the regulation or a county adopts the regulation from a county level, and then there's different or unique criteria for each of the fire authorities based on their unique hose lays, fittings, that type of information. An additional content is going to be added, and this will be a living document and updated with the user feedback and the AHJ's input. So in the utilization of this regulation, the initial regulation was at the request of the Black Forest Fire Rescue Protection District of El Paso County, Colorado. They saw the tremendous need that where the NFPA documents and the IFC documents had very general requirements, but then left it up to the AHJ, and also looking at the calculation methods. They wanted some clarity and a little bit better way of calculating, especially for new developments and subdivisions where they don't know the exact square footage yet of the house. It's kind of hard to size in accordance with NFPA if you don't have the exact size and volume of the house. The cost to develop and maintain this regulation exceeds what a single district could be expected to pay. We've got a lot of hours of development time tied up in this with the handouts and the details. As such, the adoption and utilization by a jurisdiction or a county will require a subscription service fee to the author that supports the development, the maintenance, and the consultation for using the regulation. Just as with NFPA regulations or the IFC subscription services, this regulation will have an annual subscription fee to help recover those costs, but also provide consultation in the implementation of the regulation. Therefore, the document is protected by copyright and licensed to use with the subscription fee. Email any questions or comments to us. I hope you found this introduction video useful. Watch for additional videos that go into individual sections to provide more clarity. Keep in mind that this is a living document and it will constantly be updated and revised with experience. And so make sure you look at the regulation itself for its specifics, as this is just a general overview. Thank you.